Our lesson today is on Newton's first law of motion. And the goal today, I can define or explain Newton's first and second laws and apply them to real-world applications. So I'm looking at Newton's first law to begin with. Newton is a very, very important man in terms of the field of physics. In one summer, just to give you a little bit of a background, he was attending university in London. The university, or the town itself, was kind of under a quarantine because of the disease and plague outbreaks that occurred back then. So over one summer, Newton kind of came up with the whole calculus concept, came up with his three laws of physics, which still govern our world today, came up with some gravitational stuff, and a whole bunch of fundamental or key stuff that the science world still holds true and is kind of the basis for a lot of our physics. And my question is, what did you do this summer? Exactly. You should be like Newton, coming up with all this cool stuff. So what's Newton's first law? Okay. Some people might know it as the law of inertia or heard of the law of inertia, but it's really Newton's first law. And it says, an object at rest will continue at rest until a force is applied to it. An object which is moving will continue moving until a force is applied to it. So inertia is the ability of an object to resist changing in its motion. So I simplify this down because I'm not a big person on regurgitation. I don't want you to be writing out the exact definition. What is Newton's first law? Newton simply says an object will remain in its current state of motion unless acted upon by an unbalanced force. All right. So basically, or putting it into simple terms, if I set a book on the desk in front of you and we were to watch that book would never ever move. You can try this at home. This is not a dangerous experiment. Take a book and set it on your desk and watch it. Okay? I will guarantee it will not move unless you do something to it. So at some point you'll become so frustrated, you will take a swing at the book and then it'll move because you applied an unbalanced force. Okay? Absolutely excellent way to spend a Saturday night if you have nothing better to do. All right. So let's move on to Newton's second law. Okay, Newton's second law is a little bit more exciting because Newton's first law, that's it. Okay, Newton's second law is where we actually get to do some calculations. So I love this one. Newton's second law is FU-ma. Squeeze me, you say? It's exactly that. Force unbalanced, so Fu is your unbalanced force. So Fu, unbalanced force. Unbalanced force. M is mass of object. And A is the object's acceleration. Acceleration. So there we go. There's your legend. So as I said, FU-ma. Okay. So what it's saying, and yes, there's a written definition for this if you look at it in excuse me. If you look in the textbook, there is a written definition, blah, 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 about directly proportional. Any unbalanced force causes an object to accelerate. So if you push on something greater than what's being pushed back, it will accelerate. And that's what Newton's law says. So the example I have for us, what is the acceleration when an unbalanced force of 50 newtons east is applied to a 40 kilogram person? The nice thing in this unit is that there will only be one formula that involves force and acceleration. So that is 4 or 5 less than last unit. So that should make things a little bit more enjoyable for you. Unbalanced force is 50 newtons. We're looking for the acceleration. I know the mass is 40. So looking for acceleration, divide both sides by 40. And we get acceleration is 1.25 meters per second squared. All right, so therefore, the acceleration is 1.25 meters per second squared. And I do need to put a direction. And please note that acceleration and unbalanced force will be in the same direction. Will be in the same direction. Same direction. All right, because that unbalanced force is what drives it, makes it accelerate. So it has to be in the same direction, always is. Okay, so there's sort of the beginning here. So a student, another example, a student is bowling with her friends. She gives a 7-kilogram bowling ball an acceleration of 5 meters per second squared forward. What was her net force? What net force did she apply to this bowling ball? So again, not rocket science at this point, since there's only one formula for this unit, and it has 3 terms in it. So we know it's a 7-kilogram bowling ball, gave it 5 meters per second, or meters per second squared acceleration. So we end up with 35 newtons. All right, and that would be forward. So therefore, she applied 35 newtons forward of unbalanced force. Now, just as an aside, the other day I told you that newtons was kilogram meters per second squared. So how did I know that? Off to the side here, the units for Newton. I know that force is measured in newtons. So using Newton's second law, I know that force equals mass times acceleration. So I know mass is measured in kilograms, and I know acceleration is meters per second squared. So multiplying that together, we get kilograms meters per second squared. So that's where it comes from. You just use the formula to remind yourself if it's something that you're not going to put on your cheat sheet or you're not going to memorize. Okay? The formula will always help you out with that. Next example. A driver and his motorcycle have a combined mass of 280. They accelerate from 7 meters per second to 34 meters per second, and they do that in 4.2 seconds. What's the net force acting on the driver and motorcycle? So we're looking for force. So force equals ma, mass times acceleration. I know the mass is 280. And I'm looking for force, so that's the unknown, so I should know acceleration. So at this point, I've got to stop because I don't know the acceleration, but I have a whole bunch of other information. So that means that this is a multi-step question. And I've got 2 velocities. So I have a v1 and a v2. And I can hear some people that are realizing what's happening. They're screaming at their monitor again. It's really a waste of energy. It's something you just got to accept. Now I'm given a time. So what I'm going to have to do is I'm going to have to determine the acceleration from this information, which means I'm going to be using my kinematics formulas. And that's why those people were already screaming. They realized that we are going to have to use kinematics equations here. So hopefully you didn't throw out the first formula sheet that you made yourself, because you do need it again. We will be using kinematics formulas. They are now an assumed skill, so you will need them throughout, much to your dislike or distaste. And we need them in order to find acceleration for questions like this. So we end up with 27 equals 4.2a. And divide both sides by 4.2. And we end up with 6.4 meters per second squared forward. Or I guess I'm going east. There we go. Now I can take that information and finish my question. So my force, so the applied force here, multiply that by 280, and you get 1800. So 6.4 times 280, 1792. newtons to the east. So therefore, the net force was 1,792 newtons heading east. There we are. So yes, you do need to use kinematics, or will have to use kinematics throughout this unit as they arrive. So here we go into some of the unbalanced forces. So I want to determine or find the missing quantities on this page. So for an example number 1, I've got a free body diagram provided. I've got a mass, and I want to find an unbalanced force and an acceleration. Even though it doesn't look that way, that is a terrible U. There we go. So how do we do this? Well, unbalanced force is the sum of their forces is equal to sum of the forces. All right, so quite simply put, we're just going to add and subtract the forces up. So if I assume, and I always assume right is positive, my unbalanced force here, Fu, is equal to 200. I'm going to exaggerate here. 200 is positive, plus 50, because it's heading to my right, minus 170. All right, so we have the 250, and we're going to take away 170 from that. We end up with 80 newtons. Because it came out to be a positive number, that means it's still heading to the right. So there's my unbalanced force. You're just adding and subtracting forces that are traveling on the same axes or same plane. So what we're going to do, we're going to get into two-dimensional stuff eventually here. But think of this is all on the x-axis. And this one's all going to be on the y-axis. So we're just adding forces in the same direction. Now to find acceleration, we're going to use Fu because now we know the excuse me, unbalanced force is 80. Mass is 200A. So acceleration would equal our 80 divided by 200, and we get 0.4 meters per second squared. That is to the right. Okay, so there we go. So it's like a tug of war. Now you got Susie, you got Johnny, you got Peter. They're doing a tug of war. Susie and Johnny are obviously winning, and they're winning because they have 80 newtons of force. Peter's being accelerated at 0.4 because they're overpowering him. Same thing here. Okay. Normal force. Actually, it should be force due to gravity. Bit of a typo again. Not a good roll on this slide. Okay. In this particular situation, actually no. Sorry, don't do that. Undo it. Okay. What we want to do is find our normal force here. So we are going to calculate our force due to gravity. So here is how you calculate force due to gravity. Force due to gravity is the mass of an object multiplied by gravity here on Earth. So Fg is going to equal mass of the object's 25 multiplied by 9.81. So that will tell us how much the gravitational force on Earth is pulling on this object, and it's experiencing 245.25 newtons. So the unbalanced force here, okay, so force unbalanced, and in this case, we're looking for normal force. So I'm assuming our normal force is going to be equal to, our unbalanced force here is going to be, I was going to say 0, but because they want us to calculate acceleration, I'm just going to ixnay this one right here. Forget about that. So Fu equals ma. So the unbalanced force, again, for me, up is positive. So I have 75 newtons upward. So I have 75 minus 245.25. So that's my unbalanced force, 25A. So simplifying that, minus 75. So I have negative 170.25 equals 25A. Divide that by 25, and I get acceleration is negative 6.81 meters per second squared, and that's in the downward direction.